Okay, to calculate the acceleration from a velocity time graph, we need to find the gradient. So for number one, this will be the rise divided by the run, which in this case is 89 divided by 10. So there it is there, 89 divided by 10. And that gives you acceleration of 8.9 meters per second squared. Next is to calculate the distance travelled during this time of 10 seconds, and from the graph the distance travelled is always the area under the graph, so it's the shaded area here, which is basically a triangle. So we use the triangle formula, which is half times base times height. So here it is here, the distance will equal half times the base of 10 times the height of 89, so we get 445 meters. Okay, then for number two, to find the acceleration, we need to find the gradient of this line. So it's the rise over run. In this case, we're going from 8 up to 20. That's a rise of 12. So there it is, 12 divided by the run, which was 10 seconds. And that gives us an acceleration of 1.2 meters per second squared. And then the next thing is to find the distance travelled. Now, it's this entire area here under the line, which can be done in two ways. You can find the area of this rectangle first, and then the area of the triangle there, and add them together. Or you can use the formula for a trapezium, which involves the average of these two heights, 20 and 8, and multiply by the base. So I've done that. So in the bracket here, you will see the average height, which is 20 plus 8 divided by 2, that's 14 times 10, so we get 140 meters. Okay, for number three, we need to find the gradient of this line to find the acceleration. Now notice it's not a rise, but a drop of 120. So no surprise, we have to use a negative sign there to indicate a loss of velocity. So negative 120 is the rise, the run is 12, we get negative 10 meters per second squared for the acceleration. Then, to find the distance, it's again this area here under the line, so that's a triangle, and so you can see the formula over here, half base times height is applied, so half times the base of 12 times 120, which was the height, and that gives us a distance of 720 meters. Okay, that leaves us number five. Number five, the rise again is in fact a drop. You can see it goes from 64.5 down to 32.7. There is a decreasing gradient, so we lose 31.8. Do the maths there, 32.7 take away 64.5 gives you a negative 31.8. So what we're doing there is the final speed minus the initial speed. And then divided by the base, which of course, in this case, the run is 12. So we get acceleration of negative 2.65 meters per second squared. Then to calculate the distance, again, it's this area, the total area, all the way down to the horizontal x-axis there. So I've calculated that as the area of the entire trapezium shape, and so it's the average height, which is the average of 32.7 and 64.5 times the base, which is 12. So there's the maths there, and you should get 583.2 meters.